Hey guys, what's going on? Paul here. Welcome back to another Cardano video. And in this one, I sit down with Phil and George to talk about layer 2s on Cardano and how Cardano really is primed for scaling solutions like this. And with the UTXO model, how much easier and how much more secure these types of scaling solutions could be on Cardano versus a lot of other chains with different architecture models. So some of you might remember Phil from probably a few months back. At this point, we talked about scaling Cardano with ZK solutions, and that really opened my mind to a lot of different scaling opportunities that Cardano had and left me a lot more bullish on the topic. This one hasn't disappointed and has opened up and explained a lot of the different areas to me, a lot of the trade-offs between different types of scaling with sidechains, layer 2s. They do have a Catalyst proposal in. I'll leave links to that below. Make sure you check that out. Ask questions below. We will probably do a follow-up, maybe a live stream. Timestamps are there as well because we cover a lot from introductions to layer 2, sidechains, trade-offs, why you would go with one versus the other, and talking a lot about the UX and how that needs to be made as seamless as possible. And he even talked about being able to move pools from the L1 to the L2 in times of high traffic throughput to be able to take that load off the layer 1 and then put back after. So a lot of interesting things potentially coming. So let me know your thoughts below and let's jump into it.
But the TLDR is that, like, recently we had some projects complain about throughput and move the base or whatever. With these layer 2s, this will no longer be a concern, right? If people want high throughput and don't care about things like super decentralization or the liveliness and robustness of Cardano, they won't have to leave and go to Solana or Base or whatever, right? They'll be able to use Hydra, they'll be able to use Midgard, and this is going to be great for the ecosystem.
Hey guys, what's going on? Paul here. Welcome back to another Cardano video and something a little bit different today, looking into layer 2s on Cardano and one in particular, Midgard, which is from George and Phil are a part of this. Fluid tokens are also a part of this. There is a proposal in with Catalyst. So I'm here to learn a bit more about what it is. Phil has been on before talking about some ZK solutions for Cardano. Definitely recommend checking out that one if you haven't before. But George, Phil, thanks very much for taking the time to come on, and we'll jump straight in. George, do you want to give an introduction to yourself, and then we'll get into what Midgard and layer 2s and all that type of stuff is?
Yeah, thanks, Paul. So my name is George. I've been a Cardano, Plutus, and other technologies developer since the early days of the first cohort of Plutus pioneers. I was involved in the Alonzo testnet, blue, white, and purple, whatever those colors were. And then I really dove in and got involved with a whole bunch of projects on Cardano building dApps via MLabs. So I've been working at MLabs for 2 years, since beginning of 2022 until earlier this year. I took a break, and now I'm jumping in with one proposal that's my own that I'm co-proposing with Phil, and Phil also and Anastasia Labs they have a few proposals that they're co-proposing, and I'm involved with the Midgard proposal, which we will mostly talk about today. So
great. And Phil, for yourself, people who mightn't have seen our first podcast.
Yep, I'm the CEO and founder of Anastasia Labs. It's a development and auditing firm on Cardano. We specialize in sort of practical ZK applications and security analysis of on-chain protocols. I think our main focus is open source contribution and growing the ecosystem as a whole.
Yeah, I've seen you're really big, pushing really big on open source, and there's lots of advantages for that for Cardano and building in general. But jumping into this, first off, before we get into what Midgard is, can one of you give the high level of what a layer 2 is, or why you would have a layer 2 instead of the layer 1, just for people who mightn't be familiar with it?
Yeah, sure. So there's a big landscape of different, distinct sort of mechanisms for not just scaling, but for different types of functionality, things that aren't supported on the layer 1. Specifically, like it's better to relate this to like existing examples. So in the Ethereum world, right, these things are typically broken up into 3 categories. There's a lot more than 3, but there are 3 main categories. There's rollups, which are layer 2 solutions that attempt to inherit the security of the layer 1, right? So their security isn't based on economic security, like a standard blockchain is. It's based on the security of some layer 1 protocol. So the rollups on Ethereum attempt to inherit the security of Ethereum, right? That's their main goal. And basically what they're doing is they're moving a lot of transaction processing off-chain into these rollups, and then it's sort of batched together and published on Ethereum. And this is a scaling solution. There are alternatives. So that's rollups. The second one out of the 3 I was talking about is sidechains. Sidechains are chains that are tied to one ecosystem typically. So for instance, in Ethereum, Polygon is a big sidechain. It's a different scaling mechanism, except it doesn't inherit the security of the layer 1. It attempts to have its own economic security, right? So the security of Polygon and sidechains in general are based on their own blockchain consensus and their own economic security model. And this is an important distinction because it means that their goals are quite different. Whereas a rollup is sort of like a scaling mechanism for some layer 1, a sidechain can be sort of its own independent network that doesn't necessarily need the layer 1 in any capacity, right? Polygon could just exist by itself in a silo. It is its own blockchain, right? And because of that, its consensus and economic security are much more important, right? So if you have 51% of Matic or any sidechain token, right, then you can do things like double spend, and basically the network is in trouble, right? Because its security is derived from economic security. Whereas a rollup, typically this isn't the case. So the third one is state channels, right? And in the EVM world, this is things like Plasma, semi-state channel-esque. And then in the Cardano world, this is Hydra. And in the Bitcoin world, this is Lightning. And here, it's similar to rollups in that it's a scaling approach to the layer 1 that relies on the layer 1, can exist independently, and it doesn't have its own economic security. It gets security entirely from the layer 1. But it has different trade-offs in regards to participants and membership. Those are the things that it sort of has a bad trade-off in, right? The number of participants is limited, and dynamic membership is difficult. But the good trade-offs are throughput and finality, right? So if you constrain the participants, you get very high throughput, very high finality, very fast finality. Hopefully this is a good overview of those 2 things.
I want to jump in here for a second. So zooming out a little bit, I think the big picture is that blockchains is a game of trade-offs: security versus scalability versus decentralization. I forget what the 3 or 4 or whatever of them are, but the point is you can make gains on one, and sometimes it comes at a cost on other things. And so if you have one blockchain for all, right, that picks one point in that trade-off domain, like space, right? And it's a one-size-fits-all kind of solution, which means that it's going to be very suitable for some applications that are closer to where that trade-off, that balance was struck, and less suitable for other applications that would have preferred to place that kind of balance in a slightly different place, right? So L2s and other chains in general, other blockchains, the benefit of them is that with each one, you get to move the balance towards something else, make it more suitable for some applications and slightly less suitable for others. And so diversity is the name of the game with other chains and L2s, right? So if you're talking about a whole other chain, right, then that chain has to re-implement all parts of a particular blockchain. So the consensus aspect, the ledger aspect, consensus being, are we doing a multi-signature, everyone has to sign off? Are we doing an Ouroboros Prowess type of thing where you're randomly selecting from a pool of from a group of stake pools, right? And you have kind of random people adding blocks, or you're doing the Bitcoin proof of work type of thing. Ledger, are you doing UTXO or account model or some other type of ledger technology, and so on? And for each one of those, you have to make a choice if you're implementing a whole other blockchain. But more importantly, you have to bootstrap it and get it to the point where its security model is self-sustaining. So for example, with Cardano, even with Ouroboros Prowess, if you were to launch another Cardano tomorrow, it would take some time for it to reach the same level of decentralization and security as existing Cardano does, because you need to, since Cardano's model uses proof of stake, you need to distribute that stake among a wide range of people who are globally distributed and who are more likely to be independent of each other, right? If you start a new blockchain tomorrow, it's very hard to get to that point. In fact, it might be impossible because you have the incumbents that already are spread out. So people are going to ask, well, why am I going to go to this new chain? So what L2s do is some of them will piggyback on the consensus of Cardano. So that's where the state channels and the rollups that Phil was talking about, that's where they come in, because they're able to piggyback on the pre-existing consensus and decentralization aspect of Cardano as a chain, right? But they're able to do something different in terms of the rollups and in terms of the scalability aspect of the equation, right? Mm-hmm. And so you get the best of both worlds. You get that variety while reusing some of the pre-existing bootstrap decentralized communities that exist on Cardano. Does that make sense?
Yeah. Right. The standard way you can sort of differentiate these different scaling solutions is if it is a smart contract protocol / DApp on an L1, then it is either a state channel or a rollup L2. If it is not a smart contract or DApp, if it has its own ledger, then it is a sidechain, right?
Mm-hmm. So that's the question, right? How much are they doing of their own, right? And how much are they reusing from the L1 that they're tied to? Or if they completely untether from it, right, and they don't have any remaining ties with the L1, right, then they are their own blockchain doing their own thing off in this, on the side here.
Yeah, I suppose for people watching, the simplest way is that not every DApp needs the same requirements, or each DApp or industry is willing to accept different trade-offs for what they're doing. The likes of gaming mightn't be just as worried about decentralization. Speed, cheap fees are more important for them. So with layer 2s, you can give them that and you can still inherit some of the security from the layer 1 would be a very high level understanding of it. But just before we jump into Midgard, on sidechains then, if they don't inherit anything from the layer 1, what's the connection between a sidechain and the layer 1, or why would they not just be called their own blockchain?
So sidechains, although they don't inherit security from the layer 1, they're typically developed with a specific layer 1 in mind, built into the architecture to facilitate the transfer of assets between those. So bridging in general is a hard problem and is often very centralized and trusted. When you have a sidechain, typically the sidechain node and validator system has some knowledge of the chain that it wants to bridge assets to, and this can make bridging less trusted and more trustless. Basically, it's designed to facilitate communication with that blockchain, but not necessarily inherit security from it.
Okay. Yeah, I think that's a good introduction for people, and going a little bit deeper as well, actually, into what sidechains layer 2s are, and maybe another call we could even dive further. But this one we're going to look at Midgard. So this is the proposal you have in for Catalyst. Do you want to give the high level of what it is and where it fits, I suppose, in the topics we just discussed?
Right. Yeah, that was a good primer. So essentially on that spectrum, Midgard is an optimistic rollup. So it's in the rollup category that we talked about. There's two popular types of rollups. One is zero-knowledge rollups, and the second is optimistic rollups. Zero-knowledge rollups are basically whenever you commit batches of transactions from the rollup to the layer 1, you have to submit a proof that those transactions are valid and that the result of those transactions, the resulting state, is correct. And what this means is you get instant finality. But on the other hand, submitting this proof and verifying it on chain every time you submit a batch of transactions is expensive and can often hamper throughput, especially when these proofs are very computationally complex to construct. Optimistic rollups, on the other hand, you don't actually do any validation of the incoming transactions when you publish them. So the benefit of this is you can have basically unbounded throughput because you can just publish transactions as frequently as you want. The downside of this is finality is very long, right? So throughput is very high, finality takes a big hit because the way that this is allowed, right? It sounds sort of unintuitive. Oh, you can publish anything without checking whether it's correct. But how this is made feasible is this fraud-proof system where there's basically 7 to 14 days after those batches of transactions are published for people to submit complaints that are called fraud proofs that demonstrate that those transactions are invalid or fraudulent. So in the optimistic case, this is why they're called optimistic rollups, nothing happens, right? People submit honestly, and these transactions are then considered final after the 7 to 14-day challenge period. But in the non-optimistic case, where there's a bad actor, right, who's trying to do a double spend or something and sneak it in to the state of the L1, then someone has to submit a fraud proof, which is then executed on the layer 1, and then those incoming transactions are invalidated. And that means at the end of that 7-day period, they won't be merged into the actual state.
So kind of summing up, ZK proofs is, here's a batch of transactions. In fact, I'm not actually showing you the batch of transactions. I'm showing you some summary of it, like some hash of it, right? And here's a compressed, super compressed mathematical proof that with incredibly high probability shows you that they are correct, that, the transactions correctly acted on the state, all the scripts were properly executed, the whole thing, right? But in order to prove, or in order to verify that this batch is okay, you have to work through the proof and convince yourself that the proof is correct, and it's about this batch of transactions. So that's the ZK approach on the one hand. The rollup approach is, here's a batch of transactions, or again, some summary of them, some hash, right? And here's a signature from us, the people who are putting up some collateral, some bonds, saying that we have checked the transactions and we believe that they're, everything is in order. But if we're wrong, anyone has, say, 5 days, 7 days, 2 days, whatever you want to set that time period at, to show proof, kind of pinpoint proof of where we were wrong. So show us one transaction or one script in that transaction in the big package that was done improperly. And if that proof is correct, then we will give up some of our collateral, or we will lose it, right? So that allows you, in the optimistic scenario, when everything is good and we're all honest and things are kind of chugging along, less work is required to process the batches of transactions that are going through the optimistic rollup route, because you don't have to work through or generate these these proofs, these ZK proofs that everything was correct. You're kind of just trusting the multi-signature of those people. But on the other hand, you have the security aspect where you slow things down of like how long it takes to finalize that batch, because you're saying for 7 days, anyone is allowed to come in and submit a proof that contradicts our statement, our multi-sign statement that everything is correct, right? And that will invalidate that batch and slash our deposits.
Just on that then, so as the user experience, if I'm using it, and how long do I actually have to wait? So I bridge funds in, I'm using them, I'm going there
Yep.
because it's going to be quicker. I can get my quick finality. So I might go in, do all my DeFi plays, and want to come back out an hour later with hopefully out with my profit. But is that possible?
Right,
Or
exactly. So
Right.
yes, you hit the nail on the head, right? This is the big problem, right? So the rollup, the benefit is we get, with an optimistic rollup, we get insanely high throughput. But because we traded off finality, that throughput wouldn't really be useful to users, right? If they had to wait 7 days to exit the blockchain. So how this is solved is through so yes, you can choose to wait the 7 days as a user. You can withdraw yourself, wait 7 days, and get the funds.
That's kind of the baseline user experience. If we do nothing else, right, then yes, the user will have to wait 7 days.
Right. But if you look at Optimism or the other optimistic rollups that exist, in practice, users probably don't even know about this challenge period. They just get their funds. They can enter and leave whenever they want. And this is because third-party providers, which are basically, they're called liquidity providers. It's confusing with the AMM stuff. But what they do is, as a user, if you want to, say, withdraw from Midgard, you would submit a request to withdraw. It would get routed to one of these third-party providers if you so choose, right? If you don't want to wait the 7 days. They would check the batches of transactions and verify that there's no fraud in them, right? And if they do see that, you know, your transaction and the batch that it's in has no fraud, then they will let you withdraw immediately by paying you directly, right? So basically you have 100, say you have 1,000 ADA on Midgard, and you want to withdraw that 1,000 ADA to the layer 1, and you don't want to wait the 7 days, you would basically request to withdraw through one of these. It would get routed to one of these third-party services, and they would check your withdrawal transaction, see there's no fraud, and then they'd pay you your 1,000 ADA on the Cardano L1 minus some service fee. And they can do this at zero risk because anyone can independently verify that there's no fraud, right? So if you're running one of these services, then there's no risk to you. You just have to wait 7 days to receive those funds. So basically you withdraw those funds to them, and then they would pay you immediately on the layer 1.
Yeah, let's make it more concrete. So let's say Phil and 20 other people, they're running a Midgard service, right? They're running the L2, right? And I'm a user, so I've deposited 1,000 ADA into their into the L2, and I'm doing some stuff with it, and then I decide to withdraw some amount, right? So I decide to withdraw 500 ADA, right, out of the 1,000 that I have on Midgard. So that makes it into the next batch. Let's call it batch number 347, right? And so Phil and his 20 different colleagues or independent operators that are operating Midgard, they kind of multi-sign that batch, right? And they submit it to L1. Transaction goes through, whatever. And now batch 347 is going to get finalized 7 days from now. So next week, Thursday, right? But I want to get my money out faster than that, right? I want to get my money out like in the next 20 minutes or so, right? So what can I do? Well, I can ask you, Paul, right? If you are willing to do so, please take a look at the actual batch of transactions, which you can look up off-chain, right? It's uploaded to Celestia or some data service or whatever. You can download that batch of transactions, and you can run a piece of software on your computer that just goes through the transactions and independently verifies from your perspective that everything makes sense, right? And having done that, Paul, you should be perfectly comfortable paying out the 500 ADA to me immediately, because you know that you'll be able to recover it 7 days from now, right? By submitting your claim to, after finalization. And you can either do this for free because I'm your friend and, you can do me a favor, or you can take a small cut, right, for providing the service of speeding up the waiting time for me at the exchange, in exchange for you having to wait 7 days, right? But if you're doing this for a lot of people and you're building a business out of it, you don't care about, waiting 7 days to have your funds unlocked back again, right? Because you're making little fees off of us, right? So it's a nice kind of, what's the word? Complementary service to the Midgard optimistic rollup style service.
And just for the end user, then I presume this is all automated. They don't have to hear or know because
the user doesn't even know about these things.
Yeah. Because a dApp, for example, that would be using this, right? They would both wire in the interaction with Midgard into their dApp, and they would connect to some network of these third-party liquidity providers, right, that are able to speed up the withdrawal if needed, right? And it can be done fairly seamlessly, for dApps. And well, it doesn't come for free, obviously, because someone has to build in that integration, right? But that's going to be a collaboration between us and the dApps, right? So from our end, we have to create these SDKs, or like little kits that the dApps can use to integrate the interactions with Midgard and with these third-party liquidity providers, right? And then from the dApp, they just have to somehow weave that into their UI in a way that provides a pleasant user experience to their users.
Right. And one of the nice things about this system, right, that earlier I think I might have glanced over, is that unlike a sidechain, because rollups inherit the security of the layer 1, they actually pay for this security. So like if you look at like Optimism or the other L2s on Ethereum, right? If you look at the amount of transaction fee volume that they've generated, it's very, very high. So the Ethereum roadmap has sort of shifted to accommodate these layer 2s because they realized they were making so much transaction fee revenue from the stake commitments of these layer 2s. So that should put into context this whole fraud-proof system and this whole withdrawal mechanism system. Well, all of these things are happening, right? The layer 2 itself is basically paying transaction fees and doing work on the layer 1. Whereas a sidechain, this isn't really the case.
Yeah, so I suppose what we're saying here is this isn't taken away from Cardano as the layer 1. People looking that, people are leaving Cardano to do what they want to do off it. It's actually in the bigger picture helping Cardano and helping more transactions on the layer 1, but also facilitating for dApps that need higher throughput. Look, on Cardano long term, for the chain to be sustainable, we need a lot higher TX volume, a lot more fees being generated to pay out staking rewards and secure the network. So things like this can help it because it allows dApps that mightn't build on the layer 1 right now due to different things like throughput or finality or whatever it is, they can build on solutions like yours. I think the UX around this is always the most important part of it for the end user. And we'll go a bit more into Midgard in a minute, but just on the UX, what would be a typical experience for someone who's used to using Eternal, probably the most popular wallet right now, MinSwap, the most popular DEX? They go on with Eternal, they make their swap, and they're happy. They just send the funds through the UI and they get it back. Will there be similar experiences, or will they have to essentially bridge into the layer 2 first and then interact with the dApps over there? Or how simple can we get that interaction?
Right. So one of the nice things about Cardano and the local state model and the UTXO model is, so to preface this, right, optimistic rollups have been around for a while, and there's been a ton of development and research into them, hundreds of millions of dollars, but they haven't really been done on UTXO chains. So what this means is we have some unique properties that these other optimistic rollups do not have. And we can do a lot of things because of this. We can do a lot of things that they can't do. So interoperability, for instance, becomes between the L1, making this UX sort of seamless and abstracting it away from the user becomes much easier because all state is localized. So from like a user perspective, right, you might not even know that you're interacting with Midgard at all, right? You might just be able to, turn on an option in your wallet and say, I want my transactions to be routed to Midgard during like periods of high throughput or when the layer 1 gets congested, right? And this could be sort of abstracted away from you. Alternatively, right, like you could bridge through your wallet, whenever you want to, right? You say you want to move some funds to Midgard, it would just be like a normal transaction that you make on Cardano. It wouldn't need to be like a separate bridging service that you need to go through. This is sort of a big pain point on Ethereum when you have like 50 different layer 2s and sidechains and 50 different bridges between all of them. So yeah, you can do most of this directly from your wallet.
Yeah, I have to caveat all that in that this is the potential UX that we can work up to, right? But in order for that to happen, a lot of hard work will have to be done by us and by the people that we will be integrating with, right? To kind of bring this vision about. So not just building Midgard as a core technology, that enables such an L2 to rise, but also all the different connections with all the different applications and wallets and things like that will make this into a smooth experience, right? So people have to be aware of this. This is not something that will just happen overnight through the work of one team. Yeah. The goal, I think, of our proposal is to bring the Midgard Layer 2 core technology to an MVP that will convince the Cardano ecosystem that, hey guys, there's this thing, we can run it, and you can interact with it in this way. Now let's talk about integration, and let's kind of work out all the wrinkles so that we can provide the best possible UX to our users. Right?
Okay.
Exactly. Like basically all of the economic growth of Ethereum in the past like 2-3 years has been through these L2s, right? The foundation of Cardano as a chain is actually very, very strong and powerful for facilitating these sort of L2s, because Cardano didn't necessarily focus on things that, like, for instance, that Solana has or that Ethereum has, right? Like this switching to proof of stake stuff. Cardano has focused on the decentralized and robust consensus liveness, in that, like, it doesn't have outages, and basically decentralization and resilience, right? Which are all the properties that you need for an L2, for a rollup, right? These are the things that are most desirable for a rollup. So Cardano is actually like really, really like positioned very well for this type of scaling. And the goal for Midgard, right, is to be the catalyst for many more, right? So I don't expect Midgard to be the only rollup on Cardano. It's being designed as a framework for rollups. So we expect many forks, just like, the EVM world, right? There's like 50 chains, 50 L2s that run on Optimism or Arbitrum or all these different L2 stacks. But the nice thing about Cardano is because we got to see this play out in other ecosystems. So we know the pitfalls, right? And when you're trying to fix something retroactively, right, in the Ethereum world, like they made all these L2s, they realized, oh, there are some problems with these L2s. Now let's try to make solutions for those problems. This is very difficult, right, because it's already been built. So you need to sort of retroactively like try to fit in and duct tape stuff together. Whereas on Cardano, we're aware of ahead of time of all these issues, right, of these UX issues that you mentioned, right? That's one of the biggest pain points of liquidity fragmentation, of lack of communication mechanisms between these L2s. And we're designing Midgard with these things in mind, right?
Second mover advantage, right?
It's good to have something there. Yeah, it really piqued my interest our last call where you said that Cardano was one of the best places to build these types of roll-ups, or the advantages that we actually had, because before this you would have heard that, or I had heard, layer 2s aren't really possible on Cardano, or roll-ups for different reasons. And is it the Chang hard fork enables some of these features that bring this, or was this always possible?
So the chain hard fork enables ZK rollups for sure. That wouldn't have been possible. But optimistic rollups may have been possible.
Since Vassal, probably.
Yeah, since Vassal. It's just, it hasn't yet been attempted, right? Because we've sort of heavily invested into state channels, which I think is great. I think there's a ton of utility there. But yeah, I think that it's been nice that we've had other focuses, because it allows us to actually do these things right and avoid a lot of the same pitfalls that rollups have had on Ethereum. And it's allowed us to actually mature the infrastructure that is going to make this so innovative compared to Ethereum, right? Because a lot of these design patterns that we rely on, we're still sort of in the inception phase and like being battle tested, and and nailed out in production to see, whether these things can work in practice. And now that the ecosystem, sort of the dApp ecosystem, has flourished, we see a lot more like open source availability. We see a lot more decentralized applications. The feasibility of this becomes much higher, right? Because what an L2 rollup is essentially a dApp protocol, right? It's a smart contract protocol. So the robustness of an L2 really heavily depends on the maturity of smart contract tooling and smart contract design patterns in the ecosystem, right? So when everything was closed source, this probably wouldn't have been very feasible, right? But now that there's a lot more exposure to all these design patterns, the contract languages are much more mature. We have things like Aiken, and we have a lot more tooling around this stuff. This is very feasible, and the L1 is in a great position to do it.
Yeah, we're leaps and bounds above where we were when Vassal just launched in terms of tooling and patterns.
Right. Yeah. For instance, like some of the unique stuff you can look forward to on rollups on Cardano that aren't, can't be replicated in other ecosystems are transitioning of dApp state between the layer 1 and the rollup. So for instance, on Ethereum, you couldn't imagine the ability to move a pool, a Uniswap pool, or the Uniswap protocol to an L2 and back, right? Liquidity, this would just be a very, very difficult problem because the amount of total global data stored basically that make up Uniswap or that make up AAV or any complex protocol. But on Cardano, state is localized. So a dApp is basically all state has to exist in UTXOs, right? So a pool, for instance, a DEX pool is just a UTXO. And moving that DEX pool, transitioning it to an L2 and to an L1 is just transitioning a maximum of like 16 kilobytes of data back and forth between those two things, right? And this means you can actually like move application states between the layer 2 and the layer 1.
Partial application states. So part of the application can remain. So some of the AMM pools can remain on L1 because they don't need to move to L2 for higher throughput right now. Whereas other ones that are seeing more activity, you can move them to L2.
Right. And this is what I talk about of like abstracting away this from the user, because like if you have sort of a high congestion environment, right? Say there's some coin launch or something and everyone's trying to interact with some pool, then this can be sort of off-ramped to an L2 and then, settle back on the L1 when congestion goes down, right?
Yeah, that was actually in my head. That's the example that I was thinking was you have a fairly hyped up launch. We've seen NFT launches. That's probably something can be put off onto the layer 2s as well and then come back on when it's all distributed. But you see MinSwap, and I think other dexes are looking at doing dynamic fees for when trading volumes are bigger and different things like that. Potentially, could you look at that in higher trading times that the pool is accessed through the layer 2 rather than the layer 1? And obviously that would help throughput. Again, the UX is going to be the big thing, but is things like that possible as well?
Yeah, exactly. Yeah, and there's much, much more that's made possible because of this, UTXO model. For instance, like the fraud-proof stuff is way simpler and way cheaper. One of the reasons that Ethereum needs these 14-day fraud proofs is because basically you have to replay the entire, you have to execute the L2 transactions on the L1. So say you have 5,000 transactions that happened on some optimistic rollup on Ethereum that are published to the layer 1, right? And someone wants to submit a fraud proof on them. This fraud proof then on the layer 1 involves taking the state before these transactions, the state of the L2, and applying all these transactions to them and, proving that the expected state doesn't match what is published, right? So this is a lot of work. It's very expensive. It takes a lot of time. They use a lot of tricks to limit the amount of work to make sure you don't have to do the whole thing. But yeah, it's very difficult, right? Whereas on Cardano, state is localized. So to prove fraud, you can just pinpoint specific transactions, right? And say, for instance, a double spend. you can just show two transactions spend the same input, and that's a double spend done.
So we can do something like saying, all right, in this batch of transaction number 35, in the third script that it had executing, in step number 1047, had this particular error, right? We can pinpoint it at that level of granularity, which is a very tiny step, but as long as that's the step that went wrong, we can show that and say, okay, this whole batch is worthless because we've shown some fraud for this. And that's enough, right? Whereas with Ethereum, you have to kind of, first of all, just simulating the effects of this batch. You need to have access to the global state, of Ethereum, and you have to go through it all, right? And also then to show that fraud proof is very difficult as well.
Right. So this might be sort of like intangible. People might hear this and say, oh, all the tech stuff sounds great, but why are optimistic rollups exciting on Cardano compared to Ethereum, right? And from a practical perspective, what this means is to conduct a fraud proof on Ethereum can cost hundreds of dollars, even thousands of dollars, because these transactions are very expensive and you're doing a lot of stuff. On Cardano, it can cost less than $1, right? Because it can be as simple as one Cardano transaction. And this is very impactful because one of the main criticisms of these, optimistic rollups is that no one's going to risk doing these fraud proofs if it costs so much money, right? And a lot of people don't have the money to do this in the first place, especially like a regular user isn't going to have like $3,000 of ETH to go submit a fraud proof, right? Whereas on Cardano, everyone has like less than 1 ADA for the transaction fee.
Not only that, but also the third-party liquidity providers that we were talking about, right? For the Cardano style, batches or stuff, there's less work for them that they have to do to verify that the batch is okay and to be comfortable, giving people advances on their withdrawals, right? So coming back to you, Paul, for example, right? It's a much less heavy piece of software that you have to run on your machine to verify locally that everything is okay and to make you comfortable, like providing your service, right, for people's withdrawals.
Yeah. So out of the box, Midgard is going to have basically the same behavior as Cardano. It has the same smart contract language. It has the same sort of transaction format. There are a few components it doesn't have. For instance, it doesn't have a staking system. Basically, Cardano is like a hybrid account / UTXO model where like the staking portion of stuff is sort of an account model. On Midgard, we don't have this because fraud proofs for global state is very difficult.
More complicated.
Right. So like Ethereum has this whole problem of fraud proofs for global state, whereas we say, well, let's just take advantage of Cardano's UTXO model and get rid of it. But yeah, so there's no like staking reward system on Midgard, but the benefit is that everything else is super robust, super fast, and very simple and secure. And the nice thing is that the security of it is the security of Cardano. As long as the smart contracts are secure, and adhere to their specification, and as long as Cardano is behaving correctly, then the L2 is secure, right? And this is a very strong security property. And another nice thing is that so Ethereum rollups have a large problem of bridging approaching the trustlessness gap. So if you look at something like L2B, you can see like, okay, what state of decentralization are these rollups in? Right, and a lot of them have trouble making progress in terms of openness of who can submit fraud proofs, because you can, if you're like a bad actor, you can sort of pester the network quite a bit if you just submit frivolous fraud proofs and you're fine with throwing away your money, because the network will sort of halt to address your fraud proof, and you might burn some money in the process. It could even be a lot of money. But you can, turn the network off for large periods of time. On Cardano, we don't have this problem because we talked about, this local state fraud proof system. So these fraud proofs can actually be resolved quite fast. So trustlessness, making these things more decentralized is much, much easier. And truly inheriting the entire security of the layer 1 is like much more approachable.
So I'm actually getting loads of questions in my head from everything we talked about. I'm conscious of time, so I'm going to try and go through some of them quick. But just
yeah, absolutely.
is there nodes then on the layer 2 that create these bundles, or how they get sent back to Cardano, or how is that done? And then since there's no staking to elect them, or whatever way you want to call it, like on Cardano, stake gets you more blocks and that. How does that process work for security reasons?
Right. So the nice thing is that security is entirely dependent on the Cardano layer 1. So our own consents, if we were a sidechain, right, those questions are important, right? Who's publishing it? How does the person who's publishing it get selected, right? And on Cardano, we have this huge, complex, and very robust system of like, okay, how do we select the block producer? And all these complicated components that go into that. But on a rollup, on a trustless rollup that is aiming to inherit the security of the layer 1, it doesn't matter who publishes the block. It could be just completely random. It could even be, everyone if you want to submit the block, you submit an intent to submit the block, and then it's just like a random decision. It could even be first come, first serve, right? Whoever's pinging something faster. And the reason it doesn't matter who submits a block is because all it takes is one honest actor to keep the system accountable. And the actor doesn't even need to be a validator. So if the network, a normal network, right, the number of validators is very important. If you have 10 validators, that's probably not too great if you're running your own blockchain. But on a rollup, right, you could have 10,000 validators or 10 validators or any number of validators. It doesn't matter as long as there's one honest entity, right, who has liveliness, meaning their computer is online, right? Okay. And that doesn't even need to be a validator. So say you don't trust any of the Midgard validators. One, you can, submit a bond and you trustlessly become a validator on Midgard, right? So you can become one if you don't trust the existing ones. But even if you have no intent to become one, you don't trust any of them, you can still submit fraud proofs, right? So as long as you trust yourself, or you trust some entity that exists somewhere that's willing to do this and keep Midgard accountable, right, then the security of Midgard is guaranteed, right? And this is a very strong property because, that's very rare in blockchain where you need an honest one party, right? It's always an honest majority, or at least an honest, council or multisig or something like that.
And in fact, it's even better than that, because not only do you just have to assume that there's only one honest party, we have a strong incentive for such an honest party to exist, because those third-party liquidity providers that we were telling you about, well, they're monitoring these batches anyway, because they want to be able to provide that service to users, right? And so it makes sense for them to, while they're doing that, and while they're checking for fraud anyway for each one of these batches, if they do detect it, they'll just send it in and report it, right away, because they also gain something out of it, right? Like the bounty or whatever for reporting fraud.
Right, and this
so it just makes sense.
Significant, right? So even if you're like not involved in Midgard at all, right, you have an incentive to run a program that watches Midgard and checks that everything is operating correctly. Because if you do indeed detect fraud, right, what would happen is you'd be able to submit a fraud proof, claim the bond of whoever published that fraud. So say some validator was dishonest and tried to do a double spend, right? And you're running this program, then you detect it, it submits the fraud proof. Whatever validator published that will lose their bond, which is quite significant, right? They lose a huge chunk of ADA. And then the network, those fraudulent transactions would never make it into the network, right? So it would have no impact on anyone. So as a bad actor, right, you basically have no incentive to try to commit fraud because the risk is very high, right? And you'll get nothing out of it, right? You can't, the only way to commit fraud and actually benefit from it would be to submit fraud and then pray that there's not a single party who reviews your transaction in 14 days, right? And this is very unrealistic.
Which is quite unlikely, right?
Yeah. And just on that then, so I'm a SegPool operator on Cardano. Is this something I could put onto one of my relays, or would it be big technical requirements? Because obviously this is good for Cardano if you can get lots of SPOs to throw it not onto the block producer, but onto some of the relays. It's something I don't see why people wouldn't do, is just enable it.
Yeah, exactly. The constraints of running something like this would be extremely low. So you could basically put it if it can run a relayer, then it can definitely run this, and you can definitely tag it on without much additional cost.
Okay, that's good to hear. Now, everything we're talking about here, the proposal will be linked down below. Now, I'm looking at the proposal, and it's a fairly small ask for what I'm hearing here. It sounds absolutely brilliant. I'm looking at the funds you're looking, I think, is it 500,000 ADA? And then I think you touched on it earlier, Phil, about the amount of money that's been raised for different ZK solutions in other chains. And I'm looking at hundreds of millions versus what you are. So, how is that possible, or how much work is involved in? I know you said this would be the MVP or whatever it is initially, but how is it possible so
Right.
cheap?
So regardless of what happens with this proposal, we're building Midgard, right? We have sort of in our last talk, right? I named a couple of things in the ecosystem that I thought were very important, right?
Mm-hmm.
I thought it's very important to have a high availability of open source smart contract and dApp protocols on Cardano, right? So that was the first thing that Anastasia Labs tried to address, right? We released a ton of open source public utility contracts for things like bridging, investing, and like a lot of big projects in the ecosystem are relying on this tooling and have benefited greatly from it. The second big thing I wanted to address was the lack of these community-driven L2 solutions, right? And Anastasia Labs as a company, we feel like we've made a lot of headway with the open source stuff, right? We encouraged a ton of people. We encouraged we made Genius Yield open source their smart contracts through a deal with them to audit their protocol for free. We had gotten many of our clients like Fluid Tokens to open source their contracts, MinSwap to open source their contracts, SundaySwap to open source their contracts. So we felt like we had enough of an impact in this regard to move on to the next stage, right? So Anastasia Labs as a company has sort of shifted its direction and put a pause on auditing and directing basically most of the funds that we've gathered from all the activity that we've done on Cardano and all the things we've built and audited and all the R&D work we've done to the development of Midgard, right? So right now, Anastasia Labs is a team of about 11 full-time developers, and it's full steam on Midgard, right? And regardless if this proposal gets funded or not, Midgard is happening.
But please do vote.
Yes, please do vote.
Right, because more resources will obviously allow us to do more, right?
Yeah.
So.
I definitely have my vote from going through this, and just in my head, the amount of possibilities that are here for all of this when we do get it. And timeline, what would be the timeline? Obviously, Catalyst funding, I presume, would speed up the timeline a little bit because you can put more resources, so you don't have to be doing other work to get the funds. But what's a realistic timeline for this?
With Catalyst, we're hoping 6 to 8 months from now, right? And keep in mind, it's not going to be as feature robust. It's not going to have a lot of the sort of like abstraction layers of like DEX pool moving in between the layer 2 and the layer 1, but it should be in a state that is completely usable and isn't painful or foreign to DeFi users.
And when this is operational, do ye earn some of the transaction fees? Obviously, there's probably so much more that can be built on top of this, but that's going to cost funds as well. Do you try and go back to Catalyst for more rounds, or is there a way you can earn off this to improve it then?
Right. So, we will run publishers, right? So we'll participate in the network and we'll receive fees the same way anyone else can choose to also join as a publisher / validator in the network. That will be one way, but the main thing will be just like Optimism, right, has become a framework for L2s. This is designed to be a framework for L2s, and what this means is, we've designed Midgard specifically as a basically high throughput. High frequency trading blockchain for DeFi activity, right? But there are a ton of other use cases of L2s, right? You want ZK L2s, you want supply chain L2s, you want NFT gaming L2s, and all of these things will want some framework to build on, right? And we hope that, you know, Midgard being the first and you know, hopefully the most robust and you know, modular, will be the framework that these projects choose to launch on, right? Because once you have one release, like once Optimism released their, you know, initial open source repository, tons of different people started building their own L2s with Optimism, right? And who do these projects go to for development and auditing and help? It's going to be the people who develop the framework. So that's sort of the plan for sustainability. And
okay, that's it's good to have that in place too. It's but sounds like we as Cardano are going to benefit immensely from this, and the user experience longer term is going to be really improved. And just on time, I know I've kept you longer than planned, but I enjoyed the conversation. George, before we finish up, you're also looking at another type of a layer 2 as well. Do you want to give the high level on that? And we might set up another podcast looking at that one then and go into the specifics on it, but just the high level of what it is and how it would differentiate from Midgard.
Yeah, absolutely. So the other proposal is called Hydraozoa, and that one is an evolution of Hydra. It's, well, more than an evolution. It's a fairly radical departure in some respects. And the idea there is to, from the optimistic scenario, right? So in a similar way to how Midgard tries to make everything work as scalable as possible, as fast as possible, and as cheap as possible in the optimistic scenario where everything works, and then have a backup plan or a fallback mechanism for where, you know, if things don't work out that way, if there was a fraudulent transaction or something, we can do a fraud proof or whatever. Hydraozoa tries to do a similar optimization, but to Hydra itself. So we're not doing the optimistic rollup thing. So we don't have fraud proofs. We don't have any of that kind of stuff. But what we do have is, so long as L2 consensus between the Hydra head participants holds within the Hydraozoa protocol, they are generating new snapshots like on L2 that are actionable on L1 with transactions that are as cheap as possible. So essentially, they're multi-signing like individually transactions within a batch, right, that can be submitted. And these are very cheap transactions. So these transactions, you know, to decommit, to withdraw funds out of the Hydraozoa head, I guess, it would involve like one script execution, and then the rest are just simple transactions that just distribute the funds until you reach the decommitted UTXOs that you want to reproduce on L1. So in the optimistic scenario where you open up a head and, you know, the L2 parties start to communicate with each other, and they maintain this this communication properly according to the protocol the whole way through until they decide unanimously to close down the head for, you know, in a kind of a in the right way, like, so everybody agrees and let's do it kind of in the proper step. You will have very cheap transaction fees and speed and everything to get funds in and out of the Hydraozoa head, compared to Hydra, which leans a lot more on smart contracts to execute both the commits and decommits out of the Hydra head. For Hydraozoa, these are much simpler transactions. And so we're doing a lot more work on L2 in terms of what the different participants have to do to communicate with each other, but we gain a lot simpler kind of activity on L1 to actually, you know, settle those transactions, right? While still maintaining the same fallback mechanism. So if consensus does break down on L2, we kind of fall back to something that behaves a lot more like vanilla Hydra does. So.
Okay, yeah. So we'll definitely do a call diving deeper into that. I know people have lots of questions about Hydra, and I still see out there sometimes, oh, there's going to be 1 million TPS per stake pool operator with Hydra, and I think what it can do was blown out of proportion early on, but it definitely has lots of good things. Some of the things that were a struggle initially that I seen was you had to open and close ahead to get new participants and things like that in, but we'll definitely go into that.
Oh yeah, I forgot to mention dynamic membership is a goal for the project as well. So we've simplified as much as possible the smart contracts and mechanisms that we have going on L2, and that allows us to actually have dynamic membership. So you don't necessarily need to close down the Hydraozoa head to add or remove a member. You can just have the current group of people. If they agree to let someone in or let someone out of the group, then they don't have to shut everything down. They can just say, okay, so from now on, this is the new group.
Right.
Okay.
Yeah, those numbers, this like 1 million TPS thing, it's the same with rollups in that these numbers are blown out of proportion because they're theoretical limits, right? And the reason they're theoretical limits is because these solutions, Hydra and rollups, are not bound by the speed of the layer 1, right? They get faster as the layer 1 gets faster, but they're not actually bound in any way by the throughput of the layer 1. So this means, like, if you have Hydra, where you have basically all the participants are running multi-million-dollar supercomputers, right, with insane networking, then you can have basically infinite TPS, right? But in practice, you're not going to see 1 million TPS because most people aren't going to be running billion-dollar hardware, right?
Right.
And it's the same with rollups. Like, I could throw out 1 million TPS as the theoretical limit for Midgard, and yeah, if I made the validators run like supercomputers and data centers, then it'd be possible. But in practice, it's whatever the hardware can support and the networking.
So I
Yeah,
can
and
take
I'm
that.
not going to commit to any particular performance numbers right now because obviously we have to build the MVP first, right? Like if you take Hydra, for example, Hydra does have vanilla Hydra does have an implementation right now. And so you could theoretically benchmark it and see, okay, this is how many participants we are able to handle based on the constraints of L1. And this is the amount of like the throughput of transactions that these participants would be able to handle, assuming that they're running this kind of hardware. So this much RAM, this much compute power, and so on, right, for per participant, and this good of a network connection between them, right? We can sort of measure how much we can load that L2 and see what we can do. For Hydraozoa, I'm not going to speculate right now on what the performance will be. I'll be able to like show actual benchmarks once we have the MVP. But what I can say is that the whole point of Hydraozoa is to actually relieve a lot of the bottlenecks that I saw in Hydra, right? And so to squeeze out a lot of more of it. So unless I screw up or the team screws up, it should perform better than Hydra.
Okay, and I'm going to take the snapshots of the two of you saying each of your layer 2s can do 1 million TPS per second, and you try to get
Post it everywhere.
Good snapshot.
yeah. So look, we'll definitely dive into that in another call. The link for that one, as well as the Midgard Catalyst proposals, will be down below for people who want to go and look a bit deeper. But any closing thoughts from either of you guys before we close this out?
Tons of exciting stuff coming to Cardano. Super excited for Midgard. I think that optimistic rollups haven't really been done on UTXO, so we can do a lot of really cool stuff that can't be done elsewhere. And a final closing statement is the Constitutional Committee stuff is happening. So vote for Rick and their consortium thing. Personal advice, but yeah, I think it's important, as I mentioned last time, right? A big part of scaling is going to be governance, right? And people who are interested in scaling the chain, right, who want to scale the L1 itself, maybe not Midgard, they're not interested in layer 2 solutions. A big part of that is going to be governance proposals to bump up these parameters and shift the roadmap to the things that they're interested in, right? Like if we want Laos earlier. So yeah, very exciting, not just from the layer 2 perspective, but from once this stuff falls into the community's hands, we're going to see a ton of advancement in layer 1 scaling and a ton of messing with these, experimenting with the protocol parameters and things like that.
Couldn't have said it better.
That's a good one on that. I think for me, I'd be pushing for both. You can scale the layer 1 to a certain degree. You don't want the requirements then for SPOs or that to start getting massive. So there's certain limits you want, but that's why you have layer 2s to throw stuff off there. George, I don't know if you were going to add anything else there.
No, I was just saying I couldn't have said it better myself. I'm also like very excited about the L2 stuff. Thrilled about the governance movement that we're seeing in Cardano. I think this is going to be an awesome year coming up. So, yeah.
Yeah, I think I might message Rick after this and see, can we have a chat fairly soon too, because he's always been my go-to guy for governance and having him on every so often to talk about that. But everyone watching, thanks for sticking with us. I know this was probably a bit longer than normal. Hopefully we gave people a good introduction to layer 2 sidechains, deep dive into what Midgard is and different examples on it. Please do share it out, let people know what's been built, and go and take a look at the proposals. I would encourage you to get in and vote for them as well, for the potential this can bring for everyone. Thanks for watching, Phil, George.
Yeah.
Appreciate your time.
Sorry, one last closing thought. So sorry, this has been quite technical, so it might steer a lot of people away. But the TLDR is that, like, recently we had some projects complain about throughput and move the base or whatever. With these layer 2s, this will no longer be a concern, right? If people want high throughput and don't care about things like super decentralization or the liveliness and robustness of Cardano, they won't have to leave and go to Solana or Base or whatever, right? They'll be able to use Hydra, they'll be able to use Midgard, and this is going to be great for the ecosystem. And it's going to basically put a nub, basically kill all the narratives that, like, oh, we have to do this because Cardano doesn't support what we want to do, right? Like, you want to do supply chain tracking, you just do a supply chain tracking L2. Right, you want to do gaming, you just do, Hydra. We already have Doom on Hydra, right? So I think this is really, really great for the ecosystem, and I think it's going to show off that Cardano is much more robust and advanced as a settlement layer than people think.
That right there is the snapshot that I really will take and put at the very start of the video and share out for people when I'm sharing the link to this. Thanks, guys. Appreciate it. And we'll definitely catch up fairly soon again. Best of luck with the proposal. Everyone, as I said before, share it out. Ask questions below. Maybe we do a follow-up on it then, a part 2 to go deeper into questions that the community has from this, and give it a like. It helps push it out. Thanks for watching, and I'll talk to you soon.